All right, so Unit 8, Day 2 notes. We are going to start. These are all of the objectives. As you can see, this is more than last day's notes, but these are all of the objectives that we're going to be going over today. Of course, yes, there are some with multiple objectives in the problem, but there are quite a few problems in this section today, okay? All right, so we are going to, as usual, go over the ones that have the star on them. If I feel the need to go ahead and go over some of those other ones, I will. If I just feel like it goes into the lesson. But if you go over some of those and you do not understand, please do not hesitate to email me, and we can meet during office hours or even outside of office hours, depending on if I'm available. Okay. I want to help you understand this stuff, and Math 9 is not simple. It goes into very, very difficult concepts moving forward. So make sure that you do your best to, of course, work in Alex, and definitely look at these notes to kind of help you, give you some extra help on understanding some of this stuff. Okay. All right. So simplify each expression. Assume that the variable represents any real numbers being the key here, because you will be moving into imaginary numbers soon. Use the absolute value button only when necessary. All right, so we definitely have kind of gone over that at the end of the last notes, we were starting this, but this gets into a little bit more discussion about the values and how they play a big role. For this one, it says the absolute value button. They say button because this is actually taken from Alex as a way to show you an example, but I will show you what that means as well. So first and foremost, like we said last time, when you have a square root, remember that's a square root, you would just basically divide. So you take the 16, it'd be z to the 16 and divide by 2. So your z to the eighth will be your answer there. In this particular case, because of this exponent being positive, you really don't need to worry about this absolute value button. The only way you'd worry about this absolute value button on these type of problems is when this is negative. This is odd. At this point, it's even, so you don't really have to worry about it, because no matter what number you put in here, your answer will come out positive, because raising something to the 8th power or an even power means that your answer is always positive. But if we go over here, same situation, and again, we're dividing this by 2, this becomes y to the 11th power. So let me give you a thought process, and I usually do this when I'm in class. I love to do this because this is a thought outside of the situation, but has so much to do with the situation. This is my thought, this is my thinking outside of this situation, but yet it definitely has the same, it has something to do with this, so it kind of helps you to understand what's going on here. So my thought is that if I raise something to the 3rd power, let's say that's the odd power, I raise something to a 3rd power, and it would be like, let's say a number -2, okay? Raised to the 3rd power, which is -2 times -2 times -2. -2 times -2 is 4, times -2 is -8. So this situation has a potential to have a negative answer, and we really do not want it to. If your exponent is odd, it has a potential to have a negative answer. So what they mean right here when they say use the absolute value only when necessary, they mean that in this situation, we do not want this answer to come out negative. If we put absolute value around here, that means when it comes out, it'll always be positive. So when you have an odd exponent, when you have an answer of this nature, you're going to put absolute values around it, and that's what they mean when they're saying that. So again, if your answer comes out like this, and it has like something to do with this absolute value button only when necessary, this is when you're going to use it. When you divide by 2 here and you get that exponent being odd, you want to put the absolute values on the outside. Again, here when the exponent is positive, you don't have to. All right. So in this case, this became, if you divide this by 2 because it's square root, and it became y to the 9th, we put the absolute value. Okay. All right. So let's look here. there is a way to put these in your calculator. I'm going to use the calculator when I can, and then when I cannot, I will show you how to do it the other way. You should have access to one of these. They are $12 or so at Walmart and Target. It's a very, very good investment, very well needed. These are approved for this course, so please, I'm turning the light on there. Please purchase one if you can, okay? So this, what you're going to have to do here, I would try to put in my calculator, and I'm going to show you how to do that. I literally just learned how to do this recently, so I'm very, very excited about that to show you. What you're going to do is, of course, this is not a square root, so you can't hit second x squared, which gives you the square root. This is a cube root, so it has the little 3, okay, in the front, or 4 or 7 or whatever number here. If it was a 7, it'd be a 7th root. This is cube root. There's 4th root, 5th root, and so on. So in this case, because it has the 3 in the front, I'm going to push a 3 first, okay? And then there is a button on, you're going to push the second, and then this little arrow up, it's a caret key. You're going to push that, and that'll give you like that little x root situation, okay? But the first thing you're going to put is whatever is the root. So 3, and then I push the x squared, and then I'm going to push negative 125, okay? And push enter and see if it gives me a whole number. If it gives me a whole number, I'm going to use that. If it gives me a decimal, I'm going to do something else. So in this case, it gives me a whole number. My answer is -5. So basically what it means is -5 times -5 times -5 will give you 3. And please understand what this means on the inside of the cube root. So basically what this little number is, I always call it a gatekeeper. Okay, it seems to help people to understand it that way. This little number here is called a gatekeeper, and in that number, it basically, you need to have the same of whatever inside to come out one time. So if I have, in this case, -5 times -5 times -5 is 125. If I have 3 of the same things, it can come outside of the cube root one time. -5 came out one time, because when it's the same, it can come out once. And this is the number that is the keeper of whatever, however many times it needs to come out. So in this case, there has to be 3 of the same. Same situation here for square root. If you have the square root, and this is my thought again, this is another thought. If I have the square root of 9, 9 is what? 3 times 3. And square root, the gatekeeper is 2. Although you do not see it, when you don't see it, you assume it's 2. So there has to be 2 of the same number. It comes out one time. So your answer there would be 3. That's why the square root of 9 is 3. Okay? So again, gives you some perspective. Although you're doing it in your calculator, and I got -5 when I put in my calculator, you need to really understand how you're getting -5, because soon or later, you're not going to be able to do it that way, and you're going to have to understand the concepts, okay? So I'm going to throw this in my calculator again. I'm going to put a 3 second, and then it gives me like an x root. 216 is my number under. The answer is 6. Okay, again, they do give you, when it comes out to be a whole number, you can use it this way. And then when it doesn't, we'll go into that zone. All right, evaluate the following. State not a real number is applicable. In this case, if it has a 5th root here for an odd number, okay? If that odd number is on the root, then you can have a negative number inside, okay? Because they want a real number. If it has an even root, you cannot have a negative number inside, okay? So in this case, it can have a negative number. This can definitely be an answer. This can have a real answer. This one can have a real number, a real answer, because it's positive on the inside, okay? This one has a negative on the inside with an even root. This is not a real number because of that, okay? If it was odd here, it can be positive or negative. But when it's even, it can only be positive. In this case, Odd, it's positive, it does have a root. I can throw that actually in my calculator, see if it comes out to be something that I like. Negative, and then it's 3, because again, we're going to use the roots here, the x root of 64, push enter, -4. -4 is my answer, okay? Can have a real answer. Let's see what happens if I put this in, okay? Let's see what happens when I put this not a real number into my calculator, see what happens, okay? So it looks like 4 x root of -256, push enter. Look, domain error, meaning that you cannot do it. That's no solution, okay? And let's try here. If it's a even number with a negative, we know that one's going to be not a real number. You can try it in your calculator and it will not give you, it'll give you the same error as it gave you before, okay? And this one is going to give you, like if you did put this in your calculator, I'm going to try it again just for practice. -4th root, okay, of 256, -4. Okay, so that one will give you an answer. So make sure that you realize that. If you put it in your calculator, you'll get an error. All right, so here it says, be sure to write your answer in lowest terms. Let's do the star problems. In this case, let me try it in my calculator. So what I'm going to do is put 4 and then the x root of, and then of course 81. Instead of saying divided, I'll go ahead and put my little backwards L's, because my answer, I want it to be in fraction form. If I do get an answer, the answer I got is 1 1/2. I want that to be just an improper fraction. So I'm going to push second and that AB number, and it gives me that little weird looking situation right here. And basically what it does is it's switching it to an improper fraction. So 3/2 is my answer there. Okay. Let's try the next one. Now, when the answers come out to be nice fractions or whole numbers, that's fine. Once it becomes a decimal, we don't want that anymore. Okay, we want to start doing them by hand, and I'll show you how to do that as well. No matter what, it's going to lead to that. All right, so for as long as you can, try to do it as easy as you can. All right, so cube root 3, okay, x root of 1, and I'm going to push the AB button for 64 and enter. So 1/4 is my answer there. That's nice. This calculator is really, really awesome. All right, let's try another one. The last one, 4 x root of 256. Again, that backwards L, and then 625. Grab enter, 4/5. So 4/5 there. So if Alex gives you these and you have this awesome Rockstar calculator, you can definitely use it to just answer those questions pretty quickly. All right, so it says simplify, assume that the variable represents a positive real number. Again, they're not going into imaginary numbers yet. They just want to stay in real. Make sure you know how to do all of these, and then we'll go to that. So we're doing the starred values. Let's start here. We're going to take the 5th root of 243, and then the 5th root of u to the 10th. And again, I am separating those and basically just doing them separately. My answer, whatever comes out, whatever stays in, and later on you're definitely going to see that. So what happens here is, let's try to do the 5th root of 243, see if that works for us. 5th root of 2, that little caret gives us an x root of 243. Push enter. Our answer is actually 3. Perfect. So where are we? Oh, sorry, 3. And then here, of course, you know that you're just going to take this, if this is 5th root, so what you would do is divide by 5 there, okay? So this becomes u to the 10 divided by 5 is 2. So there you go. That's your answer for that. Same thing here, cube root of 27, and then the cube root of u to the 3rd power, okay, u cubed. And 27, hopefully you know what that is, but let's look at it. 3 cube root, x root of 27 is 3. And for this particular one, again, you're dividing it by the whatever this number is here. You're going to divide it, and it becomes u to the 1. So that's just u. 3u is your answer there. And then we're going to actually do something where you can just see that, okay? And what am I saying? The next section, anytime you have a square, a number that's raised to a power in the same, okay, the same exact number is here. So 5 to the 5th, 4 to the whatever, 6 to the blah, 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 okay? Then you will get basically 1 or whatever numbers in here. So if it's w to the 5th, the answer is just going to be w. Here, x to the 6th, 6 root of x to the 6th will just be x. Whatever is in here just comes basically out. They cancel each other out. So if I'm raising w to the 5th, to the cube root of 5th root of w to the 5th, then it's just going to be w as my answer. But of course, with the absolute value button, if this is odd, which it is, it's 1, you have to put the absolute values over it, okay? Same situation as what we did earlier. If it's an odd number, which it is, because 1 is odd, we have to put the absolute value here. When you get here, basically what they're doing, they're canceling each other out, okay? Before the 4th root and raised to the 4th cancel each other out, then 8 plus 3y just comes out. And we do not have to put the absolute value around that, all right? So, because this particular situation, depending on what number it is here, it should be positive. So, let me think about that, hold on. All right, so I have to actually go back and kind of change that. I apologize. The even roots are the ones where you have to have the absolute value. So when this cancels out, again, because it's an odd root, it really wouldn't matter. The answer can be negative. So we would not have the absolute value there. But the same situation happens here where it becomes 1. We have to have the absolute value because of that even root, okay? I wanted to go back and check to make sure I'm telling you correctly. So the even root would make that absolute value necessary. Same thing here, the 6's kind of cancel each other out. The answer would be x. Why would you have the absolute value? Because of that even root, because your answer can't have a negative in it because of this is even. As we said earlier, odd doesn't really matter. It can have positive or negative, okay? So I'm glad I went back to check that for you. All right, so let's go here. The function is defined as follows. This is our function. We're replacing f with 8 first, and then we're replacing x with negative 56 after. So we're doing 2 different problems in this situation. So basically, first and foremost, you'll have f of 8. So we're replacing x with 8. And then you're going to say the cube root of 8 minus 8. All right, and it looks like the cube root of 0. 8 minus 8 is 0. And the answer is just going to be 0 there for the first one. Second one, f sub negative 6. So you're going to have the cube root of 56 minus 8. I can just throw that in my calculator. I'll say cube root, so 3 x root of 56 minus 8. Push enter. Oh, look at that. It becomes something kind of nasty. So let's do this by hand. 56 minus 8 is 48. Cube root of 48. And let's see if we can do that. Let's see if that one kind of works out for us. 3 x root of 48. Nope. Comes a nasty number just like we thought. All right, we are going to kind of leave that right there until we kind of go over how to break that down a little bit. For now, we'll just leave it this way. And then moving forward, we'll break that down a little bit more, okay? All right, so let's move on to the next page here. I have it here, sorry about that. All right, so we are writing it as an exponential expression. What does that mean? When you're writing it as an exponential expression, you're basically writing the base and then an exponent, and that's it. They do not want it as a square, like a cube root, 7th root, blah, blah, blah. They want it as an exponent. That's usually a fraction. So if your base is 5 to the 3rd power, if you have the root here, what you're going to do, this root is going to become a denominator, okay? So this is 5 3 over 7, 5 to the 3 over 7, okay? These two are basically alike. So just like we did before, like let's say that for my thought, that remember when we had 5 squared and then, or cubed, let's make that cubed so that you can really get it. Cubed, and then it had the cube root, all we would do is divide 3 by 3 and got 1. So that's why that became 5 to the 1 power. Same situation happens. You're just dividing, and this is going to be your answer in exponential form. So 5 raised to the 3/7. Same thing here. A, if you just have 1a, it's just 1, and then this becomes your denominator over 6. A to the 1/6. All right. So this one is 13 to the 1 over 5. Again, this becomes your denominator. So that's your answer. This one is z to the 6 over 7. Okay. Now let's go back to radical expression. So here we went to exponential, okay, exponential. And this one we're going to radical. So we're going from this to that. In this situation, we went from here to here. Now we're going from here to here. So like I said, this is your root. The denominator is your root. So all we're doing is writing it in radical expression. Root, this one is your root. The 5 is your root. This 2 is your root. So how are you going to write this? There's a 5 right here, so this becomes 5th root of 13 to the 1 power is just 13. Okay. If I had to write this, although it's not starred, I wanted to show you the 5th root of t to the 4th power. That becomes the top number is your exponent. Okay, top number is your exponent. In this particular situation, root is square root of x to the 1 is the square root of x. Okay. So those are your answers there. Let's look at this one. Evaluate the following. State not a real number is applicable. Let's see. All right, so for this one, again, your root is 3. So it's going to be the cube root of 8 to the 1 power. I can see if that gives me something that's not a decimal. 3 x root of 8, 2. Okay, so my answer here is 2. Can I put that? Would I be able to put like 8 raised to the 1/3 power? I like to put my fractions like that. Would that be something that gave me the same answer? Yeah, look at that. I raised it to the 1/3 power. 8 raised to that 1 divided by 2, and I put that backwards L just in case my answer came out to be a fraction. Let me try this one. Let's try this one. -343 raised to, remember that caret is the raised to, the 1/3 power. Enter. Look, my answer is -7. So you can, if you have the calculator, put that in and get your answer there, okay? All right, let's try this one. -64 raised to the 1/2 power. Push enter. -8. All right, again, pretty simple. If you have this great tool, and this is, I feel like, very necessary. All right, so now let's go to here, write your answers without exponents. Let's see if we can just put it in our calculator. Sometimes we cannot. 8 raised to the 3/4 power gives us 27. So 81. This one is 27. 27 is your answer there. 32 raised to the 3/5 power, 8. Okay. Here, 9 raised to the negative 3 over 2 power. Ooh, that one became something nasty. So let's look at that. So negative 3 over 2. Let's look at this one. We know that this right here is a square, okay, root. So it's going to be the square root of 9 to the negative 3 power. All right. So what happens there if you have 9 to the negative 3 power, something that's raised to a negative power? So with this particular situation, if you have a negative exponent inside the square root, it has to go to the bottom. So what we do is it now becomes 1 square root still over 9 to the 3rd power in that way. Okay, and we can say 9 to 3rd power because we don't want a negative exponent, 729. So this becomes the square root of 1 over 729. And would that become a square root, something that's a pretty number? Doesn't look like it. Yes, look at that. Okay, so that became the square root of 729 is 27. So this actually became 1 over 27. Okay, that's why that was pretty nasty. Let me try that again. Why didn't that work? So 9 raised to, I'm going to say, what is that? The negative 3 over 2. I'm just putting regular power. Look at that. Or 9 raised to the negative 3, and I'll put the answer like that, over 2 power. Okay, well, we got our answer to be 1 over 27 once we done it this way, because I guess not all the time you can throw it in your calculator. Once you get a nasty decimal, you can just start doing it by hand. Okay, we did that there. All right, same thing here. 5 is the root, so it's going to be the 5th root of 1 over 32, and it's raised to the negative 3 power. Okay. Anytime you have an exponent that has a negative exponent, what you're going to do to make it positive is flip. If you have a fraction, you flip the fraction. Okay. If you had a number here, you had to bring it to the bottom of a fraction, like right there. But in this case, if you had a fraction in here, you flip it. So let me give you a thought. So if you had 2/3 raised to the negative 2 power, in order for it to be positive, it becomes 3 over 2. And now that outside number becomes positive. So that's how you would make that exponent positive, by flipping that number here. And that's what we're going to do there. So the 5th root now, 32 over 1, because 1 over 32 becomes 32 over 1. And now this is going to be a cube root. Add to the cube root. So what I'll do is I'll take 32 cubed, raised to the 3rd power. 32 raised to the 3rd power, get my answer. And I can take that answer and to the 5th. So I'll say 5, this, and I'm going to say second negative will give you whatever answer you just got. Okay, that big long number is my answer. And look, the 5th root of whatever that answer was became 8. So this is actually 8. Or you can just throw this in your calculator. 5, second, x, and I'll say 32 raised to what? The 3rd power. And this will also give me 8. Okay? So we still got the same answer there. And that's my answer for that. All right, next page. Assume that the variable represents positive real number. When you have bases are alike, you add the exponent. So in this case, may look like a difficult situation, but you have to know your exponent rules. So we'll have 2/3 plus 4/9, kind of looks like that. My answer is going to come out as that, but I want it to be a, let me make it an improper fraction, 10/9. Okay, in order to do that, push second and that again, and then push enter. It gave me this weird looking thing right here. Push enter, and I got 10/9. So how would I write that as a, it says, assume that the variable represent, and it just wants you to simplify. But in this case, I can just practice by writing this as a rational. So it can be like this as an answer, or 9, the 9th root of w to the 10th power is also an answer. Okay, so either one of these, I'm not sure how they would want you to answer this, but it could either be this or this. Let's try this again. On this one, again, if you're multiplying, you add the exponents. Our exponent is 1/2 plus 4/7, and you get 1 1/4. I don't want that. I want it to be an improper fraction. So I got y and 15/14. Again, once I did that, I did 1, 2, 1 divided by 2 with my little backwards L, plus 4 divided by 7 with my little backwards L. I got my answer. Then I pushed second, and then that little ABC number again. It gave me like a weird looking thing. And then when I pushed enter, it gave me my fraction in improper form. All right. So our answer there, if you wanted to put it in where it looks like a radical, this will be your root 14. Root 14th root of y to the 15th would be your answer there. Okay. And again, there's more going on here too. You can go further than this, but I'm going to leave this here for now. But you could go further than this here. All right, you could go further, and I'm not going to go further right now, but we will be going further later. Okay. So in this particular situation, same as here. I'm not going to go this part. I'm not going to do this part next time because I want you to just understand how to get the positive exponent and then leave it there. But later on, we'll be going further. So this one, same situation. You're going to have 1/2, and you're subtracting the exponents because you have the same base and you're dividing, same base dividing exponents you subtract. So this will be 1/2 minus 3/8. Your answer will be 1/8. So x to the 1/8 is your answer there. Okay. Let's look at this one. 3/5 looks like for this particular 3/5 minus 3/4. Answer is negative. Negative. Okay, negative 3/20. Let's see. So if you have w to the negative 3/20, what happens is now it goes to the bottom of a fraction. So your answer would be 1 over w to the positive 3/20. All right. So let me see if they want you to kind of break that down a little bit more. I'm pretty sure that they do. I'm pretty sure that they do want you to break that down. So let's kind of go into it and see what they want and see how far this situation is going to go. Okay. So actually, I could have, I guess, started up here by showing you some things, but let me start here and then we'll go back to the top. Okay, so if you have the exponent at the bottom, let me kind of look and see if they want you to go there. Hold on, please. So now we're kind of going to leave it here. We'll leave it here for now. Again, later on, we're going to go into why these are not when you're talking about getting in radicals, but that's another lesson for another day. In this case, they just kind of want to make sure that you understand the rules, okay, of these exponents, rules with fractions. So in this case, with the z's, Z is going to be, you're going to add all of these exponents together because Z, the bases are all alike. So we are adding all of those exponents through our calculator. So this becomes what? -1 divided by 5 minus 3 divided by 5 plus 4, and then ABC 3, I mean that the backwards L thing 3, push enter, your answer will be in fraction form, so it'll be Z to the 8 over 15. That is your answer for that one. Let's look here. For this particular one, you have to worry about the bottom first. Let's get those together first. So Z to the 1/3 is up top. We're going to add these two at the bottom. You see how the bases are alike? You're going to add that. So you're going to add -3 and 4 divided by 4 plus 1 divided by 4. Okay, push enter, and you get -1/2. So you have Z to the -1 over 2. And of course, with these two, because they have the bases are alike, but they're dividing, you subtract those. So you're going to have -1 divided by 3 minus, because you're subtracting, -1 divided by 2. And I'm always going to push that little AB thing. Okay? Don't forget that you're subtracting the negative. So minus negative, and then your answer is 5 over 6. So it'll be Z to the 5 over 6 would be your answer there. And again, this calculator comes in handy. All right, so we're done with that page. Let me look and see. Now we're on to this page. 3, 4, 5. Yep, this is the next page. I want to say it's the last page. It's the last page. So, writing your answers without parentheses, of course, with these, raising a power to a power, if you remember, you're multiplying those two. So basically you would take 5 over 12, okay, 5 over 12, and multiply that times 2, and I get 5 over 6. So W to the 5, 6, just kind of helping you to remember exponent rules. Same thing here, 5/3 times 7/11. Okay, push enter. I don't want that nasty one. Second, and then my ABC, and I get 33. So I'm going to say Y to the 35 over 33 is my answer there. Okay, let's move to the next section. Write your answer without using negative exponents. Assume that all variables represent positive real numbers. Now, these bases are not alike. These bases are not alike. So what you would do here really is multiply this times this, multiply that times that, and then you can't really combine them, okay? So if I multiplied C to the 1/4, and then I've multiplied that 4, you should know that 1/4 times 4, if you don't know it, it's fine, but it's actually going to be 1, but we can do it together. Okay. 1/4 times 4, our answer became 1. All right. So that's why that becomes C to the 1 power. And then of course, with this, this one, you have to also multiply it by 4. So we're going to take -2 over 3 times 4, and that will give us that -2 and 2/3. We don't want that mixed number, so we're going to push second ABC, of course, and it'll give us the -8 over 3. So this will be B times B to the -8 over 3, and this one is how this one would look. You do not combine them because they don't have the same base. So if this had this does have a number, it's 1. If this was a B, I would add 1 in this, but I can't in this situation because this is a C, this is a B, not the same base. All right, same situation here. You're going to have Z to the, what, -5 over 4 raised to the 1/4 power, which is multiplying. And then you'll have Y to the 4th raised to the 1/4 power, we're multiplying. There, you should kind of recognize that. 4 times 1/4 is 1, so I'm going to leave that. But then I'm going to have 5 over 4 negative 5 over 4 times 1 over 4. My answer, negative 5 over 16. So x to the negative 5 over 16. Okay. Oh, this one can't be our answer either. Oh, sorry. I'm so sorry. This goes to show that I'm definitely not a math genius, but I work hard to understand math. That's why I kind of get it. But you can't have a negative exponent. If you do, that has to go to the bottom. So this becomes c over b to the positive 8 over 3. So that's what this is. When you're talking about having positive exponents, you can't have the negative exponent. So we're going to bring it to the bottom. Same situation here. Negative exponent goes to the bottom. This becomes y over z to the 5 to the 16th power, because the exponent is negative, we're going to bring it to the bottom to make it positive. Okay, and the y has a positive exponent, so it stays up top. So this is where we're getting into the fact that you can't really use your calculator to simplify. I'll kind of do this one too. So for 80, if you put that in your calculator, and I said the square root of 80, and I pushed enter, it gave me all these little whacked out numbers and decimals. We do not want that. We want to simplify it, and we want our answer to be in form of radical. So here, this is when you start getting into breaking things down and understanding what the square root, cube root, fifth root, seventh root, whatever means, okay? So 80 becomes 8 times 10. 10 becomes 5 times 2. 8 is 4 times 2. Okay, I usually kind of like mark those out so I know that they're gone. And 4 is actually 2 times 2. All right. So what I would do is, if it has 2 of the same, because this is square root, I'm going to circle them and bring them out 1 time. So 2 of the same 2's, these 2 come out 1 time. So they come out once, and then these 2 2's come out once, and then the 5 doesn't have a partner, so it has to stay inside. So basically, these little arrows mean that I brought 2 2's out. I brought a 2 out, and then another 2 out, and then the 5 kind of had to be inside still. Okay, the only way it could come out is if it had the same number twice, because it's the gatekeeper here is a square root. The gatekeeper is 2. If there was a 3 out here, that had 3 of the same number. Okay, so 2 times 2 on the outside is 4. And the 5 had to stay inside. This would be your answer. 4 times the square root of 5. We're going to go into that a little bit more. Let's break this down. 3 times 100. The reason why I would make that 100 is, as opposed to keep breaking it down. You could have done that here with the square root of 4 too. But again, the square root of 100 is 10. That's that perfect square you kind of want to see. You want to try, because this is kind of like really number sense, you want to try to find those perfect squares and bring those out as soon as you see them. So in this case, the square root of 100 is 10, because we know that this is 10 times 10. So both of those come out once. The 3 doesn't have a partner. So this will be 10 on the outside. Square root of 3 has to be left inside. And again, the practice makes perfect on those situations, okay? All right, so variables that are not perfect. In a perfect world, this will be a 14, and you just divide it by 2 and it comes out. But this is not always a perfect world. For square roots, again, if you have a square root only, this is kind of where it goes. So you would have 15, and you could make it w to the 14. Take 1 away and leave 1 kind of by itself. So you see how this now is even. So I could divide it by 2 potentially. So this would be 14 divided by 2 became w to the 7th, but this 1 is going to be left by itself, so I'm going to leave it inside by itself. Okay. With the square roots, the letters are a lot simpler. With cube roots and all of that, you still have to do the same concept, but I'll show you a little bit different way. Square root here, again, square root of u, make that, subtract 1 from it, put 1 by itself. That's only with square root. That again becomes 1. We know that from the what we saw earlier. Square root of with the 2, those 2 cancel out, and it just becomes 1u, and then this u is all by itself inside. Square root of 64, we should know is 8. And then this one is going to be, we're going to split it up, w to the 8th, and then 1w by itself. Okay, this will make it as even. Divide that by 2. This becomes 8w to the 4th. 8 divided by 2 is 4. and then this W is by itself. So that would be your answer there. 48, on the other hand, you would have to break down the number. 48 divided by 4 would be 4 and 12. You could break that down into 4 and 3. Okay, and I see 2 squared. So the square root of 4 is 2. So I know that's going to be 2, and I know that's going to be 2. So 2 and 2. Okay, and then the square root of 3 looks like it stayed inside. The x value here, I can make that x to the 12th and leave 1 in by itself. This one, I divide by 2. That becomes 12 divided by 2 is 6. So this will be x to the 6th. And that x is inside by itself. Now, all the numbers outside go together. 2 times 2 times x to the 6th is 4x to the 6th. All the numbers inside the square root go together. Square root of 3x. This would be your answer. This is basically really a good indication of where you're going to be going next. All these type of problems that get really nasty and ugly, cube roots added into that. This is a good bridge into day 3 notes. So I hope to see you there.